Hey everyone, today we'll be talking about high performance serverless architecture for deep learning and workflows. My name is Sean and my teammates are Ashish Poundal, Ikecheku Samuel Madhu, and Nipunam Pamudita. We will be looking into this high performance serverless architecture for deep learning workflows, which is actually a IEEE report done by Tiraj Chahal, Manu Ramesh, Ravi Oja, and Rekha, who's part of the institution, Singhal Institution Research, Mumbai, India. So they did this research, and we are just looking through this on presentation basis. So before we go any further, I'm gonna tell you more about something. So let's go and talk about uh, deep learning. Okay, so now let's look at deep learning. So how many of y'all, I don't know, if you guys have used Google Photos, have you guys seen that when you use Google Photos, then you will see people as a section. There's a section called people where it recognizes human faces. And if you go into it, it knows even in any pattern of faces that they make, or they could make a funny face, anything, still it can recognize one person, and they don't know, even if you don't enter the name for a while, it's okay, but still it'll recognize one particular person. Let's say it's my face, it'll recognize my face in every single photo wherever my face looks like. So later on, let's say you type your name in there, every single time there's a picture, you will see that it'll automatically tag you, and even in the people's section you can see that your new picture is there too. So that's somewhat of a deep learning into it, that it does it looks at every single patterns of a picture to find out a similarity, or find out, okay, this is a person, this person is one, like that type of thing. So one of the things I did, I went to ChatGPT and I asked it, what's deep learning? Give it on a technical basis. How do you answer it? It gave me a huge paragraph, but I'll read a small part of it. Deep learning is a subfield of machine learning that uses artificial neural network with multiple layers to automatically learn complex patterns and representation directly from raw data. Like I said, like your picture, your raw data, those pictures, it will keep on taking it, and it'll find the similarities, but it's there's more to it. So that is what deep learning is. I wanted you to understand it because that then it's more easy for us to go on to the next part and see what to do. So now let's go on to the contents. So now that we are covering this paper, we would like to go through each of the headings that are there in the paper itself. So we are going through abstract, introduction, and then problem statement, methodology design, architectural blueprint, implementation, results, future work, and conclusion. These are the parts which we have focused on from the paper. So we are looking at when we are looking at who's going to do each part of it. So let's say abstract and introduction will be done by Ashish Poundal, and problem statement to architectural blueprint will be done by Nipuna Pamudita, and then implementation will be done by me, Seruban Pirshan, and then research to conclusion will be done by Aiki Samuel. So now I'll hand it over to Ashish so he can start with abstract. Here you go, Ashish.
Good morning, everybody. And today I am here to discuss about the serverless architecture. As we all know, the what actually the serverless architecture is. The serverless architecture is the architecture like where we don't need to manage our resources. We don't need our own infrastructures. We don't need to manage our resources. That's why we can say like the serverless architecture is a fast growing model which helps for the deep learning interfaces. And the serverless architecture, these are being popular these days because like they provide the automatic scaling for the machines, or the automatic scalings for the traffic. And what happens for the particular time, for an example, in our college, like there is on the water tap, And the water tap, like if your bottle is like this small, it only gives the small amount of water, like the one bottle full of water. And even if the your bottle is big and like you need the full water, like it will automatically gives that. And like that, what happens, like if you use the serverless architecture, you only need to pay for you use. If you use the small bottle, you need to pay a small amount of money, and if you need the big bottle, and then you need to pay the big amount of money. And but while running the serverless architectures, the researchers here, they face the many challenges because of these stateless functions and the limited resources such as storage and the memory. And that's why like they propose the methodology and architecture to migrate the deep vision applications into the cloud services. But on this particular research, we are going to use the Google Cloud Services as a platform. And using the Google Cloud as a services as a platform, we uses the different cloud functions, Cloud Run for hosting the interface APIs, VPC server connectors for securing the networks, and cloud storage and file storage for the large model hostings and streamings, and to process the document, to read the document, like we uses the different production document processing pipelines. And that's the thing. And now I'm going to talk about the, as I previously described about what actually the serverless computing is. And we also knew that in the serverless computing, we don't need to manage our own resources, like we don't need to manage our own servers, and like the security for the applications also, like we can just give the tasks to the cloud providers, which will be like easier for us, and we don't need to take that much of burden about the thing. And here in this particular research, we can see the figure over there, like that there is a deep learning application scalability and low latency is required for the deep learning applications. And mm for that reason, like we faces the different kind of challenges, like the traditional infrastructure challenges, such as if we need to manage our own servers, if we need to manage our the architecture, like with our own servers. And it will be like it will also like gives the scalability problem, and like the cost, like it will be more costly. But on that place, if we use the cloud functions, like the cloud platforms like Google Cloud, and then it will be easier for us, because like they provide the storage and memories for the developers. Because like and the another the interesting thing is that, like if we need the more memory or the more storage only for the certain period of the time, the cloud providers will provide that thing. Because like we don't because like we only need to pay the things as we use. That's why, like if we use like the little bit more like little bit more storage or the memory for a particular period of time, then we only need to pay for that particular period of the time. That's why it is like the cost effective also. And here in this research, we use the uh, uh, and here in this feature as a Google, using the Google Cloud as a cloud platform, we uses the Google cloud functions and cloud runs to host the applications. And here, for the storage facilities, like we use the cloud storage and the file storage to host and stream the large data models. And to secure our network, to isolate our network, like we use the virtual private serverless connectors from virtual private connectors. And we uses the document processing pipeline in the production, where the documents are scanned, read, and processed automatically. And because of that, like we got because of that we got the seamless scaling reduces our ideal costs and consistent low latency interface, which is the very which is very beneficial for the developers to run their applications, and which will also reduce
The problem with deploying a large scale deep learning applications on premises is the underutilization of resources. Everything from power to bandwidth is being underutilized, which means generally wasted. So, this is a general problem serverless is supposed to solve. And in public cloud in general, this is a problem. This is one of the problems of on-premises on-premises infrastructure, which public cloud is supposed to solve. But when it comes to deep learning applications, there are certain problems we need to address. Some of them being call start times, file systems, etc., etc. So, in order to address those problems, um, this study recommends three pillar approach. Let's look into those. So first one being resource optimization, but by that I mean optimizing the libraries like PyTorch, TensorFlow, Unsloth. Essentially, we have to download all the libraries and fork it and remove all the unnecessary functions which we will not be using. That will greatly reduce the greatly reduce the size of our application, which means it will the startup or call start time will be extremely low. And second one being intelligent storage solutions. But that means usually there are certain tasks which there are most machine learning tools like PyTorch, TensorFlow only support NSFS for some particular task like data streaming. So it's essential for us to have a NFS file system attached to the serverless infrastructure. But the problem is that can be expensive and it's difficult to maintain and it's costly. So so the way we are trying to solve that is first we are going to have our data lake or data set inside GC, GCS, Google Cloud Storage, and then we are gonna move those files into file store when we need it. And second one being proactive provisioning, which means having a minimum or micro instances running with all the libraries preloaded. So call start, we can get that call start time down to minimal amount. Now let's have a look into the actual general architecture blueprint. First, data will be uploaded to the GCS, and then there will be a trigger which could be a scheduler or a queue, and then cloud function is gonna start executing the task. So essentially a cloud function has to move the files from GCS to file store, and then it's gonna process the data, and then it's gonna store that processed data inside GCS, and we are going to use logs and metadata in cloud monitoring and file store. Thank you.
Thank you, Nipuna. Now, let's look into this how a document could be used for deep learning, how will we upload it and use it for deep learning. So, in this thing, so let's see, we have uploading this particular document, and this document is then when you upload this document itself, a trigger is set that when you are uploading a document, the cloud function will be activated and it will start to look into that particular document. So a trigger will even trigger, which will see this thing is happening. Oh, there's a document. I look into it. So this what document will this cloud function, what it'll do is it will split it into small pieces, and then it will store them temporarily in Cloud Firestore. And then when these are stored in the small pieces in the Cloud Firestore, parallelly they'll be called small mini robots or mini functions, which will look into these small pieces and see where I could find a text. And then it knows where it finds the text and everything, and it gets that data. So it knows where to see that. After that, it'll take that whole picture back again, send it to Tesseract OCR, which is an open source solution, which will give it to that. At the same time, it will give it this parallel cloud has already found some spaces. Oh, this is where the texts are, this is where it is. All these things will also be sent to Tesseract OCR. Then Tesseract OCR looks through these things and will find out, oh, this is what it's trying to say. It reads the whole thing. Now that it knows where the text is, it'll read it and it knows what to say. It later stores it back in the results to the cloud storage back again. So this is what happens. So let's give it more of a more easy understanding. Um, we chop a lot of woods, and then these woods, we chop one big chunk of wood and we are storing this. Now we want to know what's inside this wood, or let's say we want to see what we can do with this wood. So what we do, we try to chop it into what the function does. It chops it into small parts, and this mini robot comes in. He comes and he looks at this thing and he finds out, oh, we can do this from this particular section of wood. Another robot sees another part of beam or another wood, and he says, oh, he can do another work there. We can do another work there. We can do a chair in this particular wood part, B part, or a table can be done here. Then we send all these data that this mini robots got, and we send this at the same time. We send all of these wood together as a glue. We glue it all together, and we send it. Let's say we send that back to OCR, which is a smarter robot. It learns every single thing these guys are saying, and then from that, it'll tell it then, okay, from this particular wood, we can do all these things from these sizes, and it'll store it all in this information inside itself, or it'll store it in another file, and it will keep that wood safe for later usage. So that's the implementation. Now I'll hand it over to Aiki to do the results, the conclusion, and future works.
Hi, I'm Samuel. Still on our presentation, high performance serverless architecture for deep learning workflow. So, as you heard from my previous group members, we've spoken on how the need for serverless architecture to enhance deep learning. So the project basically focuses on deep learning in, interference using serverless architecture on Google Cloud. So the traditional deep learning setup struggled with cost, scalability, and managing infrastructure. So with the use of the serverless architecture now, we're going to use this to solve the various problems the traditional setup had. So with that being said, let's look at the results and takeaways from those projects. So for the result now, the major points driven out were based on the performance and the cost analysis. So for the performance, serverless architecture scales linearly without performance degradation, in a sense that serverless helps with performance without degrading the work being done or reducing the complexity of what's being handled. Also, efficient scaling effectively eliminates cold start latency. So, serverless architecture helps to eliminate cold start latency. So, for cost analysis, we're looking at how various components or serverless architecture helps to reduce high cost. So the cloud file store, which is a feature on the serverless architecture, provides superior latency compared to cloud storage. Furthermore, optimal cloud function memory balances cost and performance. And lastly, the scaling features cost effective due to reduced execution times. So let's look at the future works. These could be the works that could be done later on with the aid of serverless architecture. We have detailed analysis of workloads to optimize resource allocation and further reduce code start. So with the aid of serverless architecture, we could use this to have detailed analysis of workloads, which aids in optimizing resource allocation and furthermore helps in reducing cold start. Another future work that could be done with the aid of serverless architecture is implementing of the Google Cloud Publish and Subscribe for improved scalability, reliability, and message handling. The third one is explore integration of cloud big table for efficient real-time data management and reduce latency. So with the aid of serverless architecture, we could explore integration of big table for efficient real-time data due to data comes in a bulky and robust form in real time. So this helps to integrate the management and reduce latency. So with that being said, we're going to um we're going to see our final takeaway and conclusion on this project. So as modern age comes by, we can all see the need for AI in solving most of our daily tasks and projects. Where we now in the world we need AI for solving or aiding into project building, tax modification and all. And most of these tasks and project building require large amounts of data to be consumed. And we can't use our traditional setup or traditional storage system. We need to make use of the serverless architecture system because this helps improve the storage system, scalability function, reliability, and makes the process easy. So, in conclusion, as organizations continue to adopt AI-driven solutions, the demand for scalable and cost-efficient infrastructure to support deep learning interference has grown substantially. This project, in which we've concluded, has explored how serverless computing meets these demands through the deployment of deep reader application. By leveraging the elastic nature of serverless platforms and integrating them with cloud native storage and compute resources, we've achieved efficient processing of high throughput image data without compromising on performance or cost. So, with that being said, serverless architecture significantly enhances scalability and cost efficiency for deep learning interference, especially with busty workloads. So, with the nature of how our workloads are robust and busty, serverless architecture significantly helps with scalability and cost efficiency for deep learning interference. So, on our conclusion basis, the Deep Reader case study demonstrates that leveraging serverless resources like Google Cloud Functions, Cloud File Store, and Cloud Storage, comparable to AWS Lambda, EFS, and S3, optimizes performance and cost. Also, strategic solutions such as provisioned concurrency, um, elastic file storage for storing, and cold start mitigation techniques effectively address serverless computing limitation. So, the use of EFS for storage and cold start mitigation techniques help to address the limitation in serverless computing. And lastly, the proper methodology and resource planning. With the aid of proper methodology and resource planning, serverless is a powerful and practical option for deploying large, complex learning applications. So, with all these points we've given out, we hope we've been able to establish the fact on the need for serverless architecture for deep learning workflows. We hope we'll be able to show why we need the serverless architecture to help us enhance deep learning workflows. Because as technology comes by in different forms and the drive for AI, the deep learning workflows in which we'll be seeing in future will need a serverless architecture system or an architecture platform to help us to handle this learning workflow. Thank you very much.